Hello and welcome to the Hospital Near Me Medical Career Training channel. Today we are working on the Medical College Admissions Test, or MCAT, to get you into medical school. Today's featured hospital is Elizabethtown Community Hospital. Their address is 75 Park St, Elizabethtown, NY 12932. Their phone number is 518-873-6377. In this video, we'll explore key concepts in chemistry from voltage and energy to chemical properties found on the periodic table. Stay tuned to learn how these elements of chemistry influence our everyday lives. Join us as we dive into the fascinating world of chemistry, exploring topics such as voltage, energy, chemical properties, and more. Discover the connections between these concepts and how they shape our understanding of the natural world. Do you need to talk to someone? Get confidential help through talking with a full-services professional listening company. Reduce your stress and increase get problem-solving help today. Click on the link in the description that says, "Let me help you in life." Increase your peace, get problem-solving help today. Question 1. Voltage and energy. Explanation of voltage and its relation to chemical reactions. How energy is involved in chemical processes. Understanding voltage and energy expenditure in electrical circuits. Voltage, denoted as V, is a fundamental concept in electrical circuits, crucial for understanding the flow of electric charge and energy expenditure. In the context of circuits, voltage represents the electrical potential difference between 2 points, typically measured in volts, V. This potential difference drives the flow of electric charge, creating an electric current within the circuit. In accordance with Ohm's law, voltage V, current I, and resistance R are related by the equation V equals IR. This equation highlights the relationship between voltage, current, and resistance in a circuit. Specifically, it states that the voltage across a circuit, V, is equal to the current passing through it, I, multiplied by the resistance encountered, R. When analyzing energy expenditure in a circuit, understanding the relationship between voltage, current, and resistance is essential. The energy expended in a circuit can be calculated using the formula E equals VQ, where E represents the energy expended in the circuit, measured in joules, J. V denotes the voltage across the circuit, measured in volts, V. Q signifies the charge passing through the circuit, measured in coulombs, C. This formula demonstrates that the energy expended in a circuit is directly proportional to both the voltage across the circuit and the amount of charge passing through it. Furthermore, power P in an electrical circuit, which represents the rate at which energy is expended or transferred, can be calculated using the formula P equals VI, where P denotes the power in the circuit, measured in watts, W. V represents the voltage across the circuit, measured in volts, V. I signifies the current passing through the circuit, measured in amperes, A. Understanding the relationship between voltage, current, resistance, energy, and power is fundamental in analyzing electrical circuits. On the Medical College Admission Test, MCAT, questions related to voltage and energy expenditure in circuits may assess a candidate's ability to apply these principles to various scenarios, including biological systems or medical devices reliant on electrical circuits. Such questions may require students to interpret circuit diagrams, calculate voltages, currents, energies, or powers, and apply these concepts to solve problems effectively. In summary, voltage plays a pivotal role in determining the energy expenditure and power consumption within electrical circuits. Understanding the relationships between voltage, current, resistance, and energy is crucial for success on the MCAT and for comprehension of electrical systems in various scientific and medical contexts. Question 2. Similar chemical properties on periodic table. Overview of key chemical properties found on the periodic table. Exploration of similar chemical properties among elements. Understanding similar chemical properties on the periodic table is crucial for students preparing for the MCAT, Medical College Admission Test, especially in the context of organic chemistry and biochemistry. Here's some college-level information. Group trends. Elements within the same group, vertical columns, on the periodic table often exhibit similar chemical properties due to having the same number of valence electrons. For instance, Group 1 elements, alkali metals, such as lithium, Li, sodium, potassium, K, all possess one valence electron, leading to similar reactivity, especially in forming ionic compounds with halogens. Period trends. Elements within the same period, horizontal row, on the periodic table exhibit gradual changes in chemical properties as you move across the row. For instance, within period 3, sodium is a highly reactive metal, while chlorine, Cl, is a non-metallic halogen gas. The transition from metallic to non-metallic properties across a period is a significant trend. Electronegativity. Electronegativity is the ability of an atom to attract electrons towards itself in a chemical bond. Elements with similar electronegativities often exhibit similar chemical properties. For example, elements like oxygen, O, and sulfur, S, have relatively high electronegativities, leading to similar behavior in forming covalent bonds and participating in redox reactions. Ionization energy and electron affinity. Ionization energy is the energy required to remove an electron from an atom, while electron affinity is the energy released when an atom gains an electron. Elements with similar ionization energies and electron affinities tend to exhibit similar chemical properties. For instance, elements like fluorine, F, and chlorine, Cl, have high ionization energies and electron affinities, making them highly reactive nonmetals that readily form negative ions, anions. Metallic character. Metallic character refers to the degree to which an element exhibits metallic properties. Elements on the left side of the periodic table, metals, tend to lose electrons readily and form positive ions, cations, while elements on the right side, nonmetals, tend to gain electrons and form negative ions, anions. Elements with similar metallic character often exhibit similar chemical properties. For example, metals like sodium, Na, and potassium, K, are both highly reactive and readily form positive ions in chemical reactions. Understanding these trends in chemical properties based on periodic table trends is essential for predicting the behavior of elements and compounds in various chemical reactions, which is a fundamental aspect of organic chemistry and biochemistry, both of which are critical topics on the MCAT. Question 3. Law of conservation of mass. Explanation of this fundamental law and its implications in chemistry. The law of conservation of mass, fundamental principle in chemical reactions. Introduction. The law of conservation of mass is a fundamental principle in chemistry that states that in a closed system, mass is neither created nor destroyed in a chemical reaction. This law, proposed by Antoine Lavoisier in 1789, laid the foundation for modern chemistry and is essential for understanding chemical reactions and stoichiometry. On the MCAT exam, a thorough understanding of this law is crucial for success in the chemical and physical foundations of biological systems section. Conservation of mass. The law states that the total mass of substances involved in a chemical reaction remains constant before and after the reaction. This means that the mass of reactants equals the mass of products. Closed system. The law of conservation of mass applies to closed systems where there is no exchange of matter with the surroundings. In practical terms, this means that reactions occurring in a closed container, where no mass enters or leaves, adhere to this law. Stoichiometry. The law of conservation of mass forms the basis of stoichiometry, the quantitative study of reactants and products in a chemical reaction. Stoichiometric coefficients in balanced chemical equations represent the relative amounts of reactants and products, ensuring that mass is conserved. Mass spectrometry. Mass spectrometry is a technique used to determine the molecular mass and structure of compounds. The principles of the law of conservation of mass underlie mass spectrometry, as the total mass of ions detected must equal the mass of the compound being analyzed. Limitations. While the law of conservation of mass holds true for macroscopic chemical reactions, it may not apply at the atomic or subatomic level due to nuclear reactions or relativistic effects. However, for most chemical reactions encountered in biological systems and everyday life, the law is an accurate predictor of mass conservation. Example: consider the combustion of methane CH4 in oxygen O2 to produce carbon dioxide CO2 and water H2O, CH4G plus 2OG, CO2G plus 2H2O G. According to the law of conservation of mass, the total mass of methane and oxygen before the reaction must equal the total mass of carbon dioxide and water after the reaction. This principle allows chemists to predict the quantities of reactants needed and products formed in a chemical reaction. The law of conservation of mass is a fundamental principle in chemistry that that governs the quantitative aspects of chemical reactions. Understanding this law is essential for solving stoichiometry problems and interpreting experimental data in various fields, including biochemistry and pharmacology.
Question 4. Solubility of solids. Discussion on solubility and how solids dissolve in liquids. Solubility refers to the ability of a substance, solute, to dissolve in a solvent to form a homogeneous mixture called a solution. When it comes to solids, understanding their solubility behavior is crucial, as it impacts various chemical processes and biological phenomena. Factors affecting solubility. Nature of the solvent and solute. The compatibility between the solvent and solute molecules significantly influences solubility. Polar solvents tend to dissolve polar solutes, while nonpolar solvents dissolve nonpolar solutes. Temperature. In general, solubility increases with an increase in temperature for most solid solutes in liquid solvents. This is because higher temperatures provide more kinetic energy to solute molecules, allowing them to overcome intermolecular forces and mix more readily with the solvent. However, there are exceptions, such as the dissolution of gases in liquids, where solubility typically decreases with increasing temperature. Pressure. Unlike gases, pressure has minimal effect on the solubility of solid solutes in liquid solvents. Hence, changes in pressure are not a significant factor in determining the solubility of solids. Solute-solvent interactions, like dissolves-like principle. This principle suggests that substances with similar polarities tend to dissolve in each other. Polar solutes dissolve in polar solvents, and nonpolar solutes dissolve in nonpolar solvents. For example, sodium chloride, NaCl, a polar compound, readily dissolves in water, a polar solvent, due to the strong dipole-dipole interactions and hydrogen bonding between water molecules and ions. Hydration and solvation. When a solute dissolves in a solvent, individual solute molecules are surrounded by solvent molecules. In the case of water as the salt or as the solvent, hydration, the solvent molecules form favorable interactions with the solute, stabilizing its individual particles and preventing them from reaggregating. This process is crucial in various biological systems where solubility determines the availability of nutrients and metabolic reactions. Solubility product constant, KSP, for sparingly soluble salts, such as silver chloride, AgCl, or calcium phosphate, Ca3PO42, the equilibrium constant for the dissolution reaction, known as the solubility product constant, KSP, describes the extent of solubility under specific conditions. The KSP expression for a salt dissolution reaction in water is the product of the concentrations of the ions raised to their stoichiometric coefficients. Knowledge of KSP values and their relationship to ion concentrations allows for the prediction of whether a precipitate will form when solutions of different salts are mixed. This understanding is fundamental in analytical chemistry and qualitative analysis techniques. Common ion effect. The presence of a common ion, either from another soluble compound or from the dissociation of the sparingly soluble salt itself, can significantly affect the solubility of a solute. According to Le Chatelier's principle, adding a common ion to a solution at equilibrium shifts the equilibrium towards the formation of the sparingly soluble salt, thereby decreasing its solubility. This effect has important implications in various chemical processes, including the precipitation of salts from solution and the behavior of buffers in maintaining pH levels in biological systems. Understanding these principles is crucial not only for success on the MCAT, but also for comprehending various chemical and biological phenomena encountered in academic and professional settings. Question 5. Homogeneous Solution Tyndall Effect. Understanding homogeneous solutions and the Tyndall effect. Homogeneous solutions are mixtures where the solute is evenly distributed throughout the solvent. These solutions are transparent and do not scatter light, due to the small size of the particles involved. However, under certain conditions, even homogeneous solutions can exhibit a phenomenon known as the Tyndall effect. The Tyndall effect, The Tyndall effect is the scattering of light by colloidal particles or suspended particles in a transparent medium. This effect is named after the 19th century physicist John Tyndall, who first observed and described it. When a beam of light passes through a colloidal solution or a heterogeneous mixture, the light gets scattered by the dispersed phase particles, making the path of the light visible. Homogeneous solutions and the Tyndall effect. In the case of homogeneous solutions, which typically consist of solute particles at the molecular level, the Tyndall effect is not observed because the particles are too small to scatter light effectively. However, under certain conditions, homogeneous solutions can exhibit colloidal behavior, resulting in the manifestation of the Tyndall effect. Factors influencing the Tyndall effect in homogeneous solutions. Particle size. Even though the solute particles in a homogeneous solution are typically molecular in size, certain chemical reactions or physical processes may lead to the formation of larger colloidal particles. If these particles are large enough to scatter light effectively, the Tyndall effect becomes observable. Aggregation. Aggregation of solute molecules into larger clusters can occur under specific conditions such as changes in temperature, pressure, or concentration. These clusters may behave as colloids and scatter light, causing the Tyndall effect to become apparent. Chemical composition. Some substances, when dissolved in a solvent, may interact to form colloidal structures due to specific intermolecular forces or chemical reactions. These colloidal structures can scatter light, resulting in the observation of the Tyndall effect in what would otherwise be a homogeneous solution. Applications and significance. Understanding the conditions under which the Tyndall effect can occur in homogeneous solutions is crucial in various scientific fields, including chemistry, biology, and environmental science. It allows researchers to study the formation and behavior of colloidal systems, which have significant implications in areas such as drug delivery, nanotechnology, and environmental remediation. In summary, while homogeneous solutions typically do not exhibit the Tyndall effect due to the molecular size of the solute particles, certain conditions can lead to the formation of colloidal structures within these solutions, resulting in observable light scattering. Understanding the factors influencing the Tyndall effect in homogeneous solutions is essential for both theoretical comprehension and practical applications in various scientific disciplines. Question 6. Salt water and boiling point explanation of how salt affects the boiling point of water. When discussing the boiling point of salt water, it's essential to understand the concept of boiling point elevation, a colligative property that depends on the number of solute particles present in the solution. Boiling point elevation. When a non-volatile solute, such as salt, NaCl, is dissolved in a solvent, like water, H2O, the boiling point of the resulting solution increases compared to that of the pure solvent. This phenomenon occurs due to the disruption of the solvent's vapor pressure by the presence of solute particles. As a result, a higher temperature is required to reach the same vapor pressure as the pure solvent, leading to an elevation in the boiling point. Van't Hoff factor. The extent of boiling point elevation is quantified by the Van't Hoff factor, I, which represents the number of particles formed per formula unit of solute when it dissolves in the solvent. For ionic compounds like NaCl, which dissociates into Na plus and Cl ions when dissolved in water, the Van't Hoff factor is typically greater than 1. This is because one formula unit of NaCl dissociates into 2 ions, resulting in an I value of 2. Calculation of boiling point elevation. The change in boiling point, delta Tb, can be calculated using the formula. Delta Tb equals IKM, where I is the Van't Hoff factor, K is the ebullioscopic constant specific for the solvent, M is the molality of the solution, moles of solute per kilogram of solvent. Importance in real-world applications. Understanding the boiling point elevation of salt water has significant implications in various fields, such as cooking, chemistry, and environmental science. For instance, in cooking, adding salt to water increases its boiling point, which affects the cooking time of food items. In chemistry, boiling point elevation is utilized in techniques like boiling point determination to determine the purity of substances. Furthermore, in environmental science, it's relevant for understanding the behavior of saline solutions in natural bodies of water and their impact on ecosystems. MCAT relevance. The concept of boiling point elevation, particularly in saltwater solutions, is pertinent to the chemical and physical foundations of biological systems section of the MCAT exam. Questions related to colligative properties, including boiling point elevation, may appear in passages or discrete questions, assessing candidates' understanding of these principles and their ability to apply them in various contexts. Understanding the interplay between solute-solvent interactions and their effects on physical properties like boiling point is crucial for medical students, as it lays the foundation for comprehending physiological processes, drug formulations, and various other aspects of biological systems.
Question 7. Pressure on a liquid solution. Overview of how pressure impacts the properties of liquid solutions. Understanding pressure effects on liquid solutions. Pressure plays a crucial role in determining the behavior of liquid solutions, particularly when dealing with gases dissolved in liquids. The principles governing the effects of pressure on liquid solutions are fundamental in various fields such as chemistry, biology, and environmental science. In this discussion, we will explore how changes in pressure affect the properties and behavior of liquid solutions, focusing primarily on gas-liquid systems. Henry's law. Henry's law states that the solubility of a gas in a liquid is directly proportional to the partial pressure of that gas above the solution at a constant temperature. Mathematically, it can be expressed as C equals Kp, where C is the concentration of the dissolved gas in the solution, P is the partial pressure of the gas above the solution, and K is Henry's law constant, specific for each solute-solvent pair at a given temperature. This law implies that an increase in pressure leads to a higher concentration of dissolved gas in the liquid phase. Effect of pressure on boiling and freezing points. In a closed container, an increase in pressure raises the boiling point of a liquid and lowers its freezing point. This phenomenon is utilized in pressure cookers, where elevated pressure allows cooking at higher temperatures, reducing cooking time. Conversely, decreased pressure, as observed at high altitudes, lowers the boiling point of liquids, affecting cooking times and processes. Gas solubility and decompression sickness. In the context of biology and medicine, understanding the effect of pressure on gas solubility is critical in explaining phenomena like decompression sickness or the bends. During scuba diving or high-altitude flights, individuals experience changes in pressure, causing gases, such as nitrogen, dissolved in body tissues to come out of solution. If the rate of depressurization is too rapid, bubbles can form in the bloodstream, leading to symptoms ranging from joint pain to neurological impairment. Osmotic pressure. Osmosis is the movement of solvent molecules through a semi-permeable membrane from a region of lower solute concentration to one of higher solute concentration. The pressure required to prevent the flow of solvent molecules across the membrane is called osmotic pressure. Pressure impacts osmotic processes, influencing phenomena like cell volume regulation in biological systems. Industrial applications. Understanding pressure effects on liquid solutions is crucial in various industrial processes. For instance, in carbonated beverages, higher pressures increase the solubility of carbon dioxide in water, contributing to the fizziness of the drink. Similarly, in chemical manufacturing, controlling pressure is essential for optimizing reaction rates and product yields. Pressure significantly influences the behavior and properties of liquid solutions, particularly in gas-liquid systems. Henry's law, changes in boiling and freezing points, biological implications like decompression sickness, osmotic pressure, and industrial applications are all manifestations of the intricate interplay between pressure and liquid solutions. Mastery of these concepts is essential for success in various scientific disciplines, including chemistry, biology, and medicine, and is pertinent for exams like the MCAT. Question 8. Nonpolar molecules and their regions. Introduction to nonpolar molecules and their characteristics. Nonpolar molecules are characterized by their symmetrical distribution of charge, resulting in a neutral overall charge. This arises when the electronegativity difference between atoms in a molecule is negligible or non-existent. Consequently, nonpolar molecules do not possess a significant dipole moment and do not readily interact with electric fields. Common examples of nonpolar molecules include diatomic gases like nitrogen, N2, oxygen, O2, and noble gases such as helium, He. In considering the regions within nonpolar molecules, it's essential to examine their electron distribution. For instance, in diatomic molecules like nitrogen and oxygen, O2, each atom shares electrons equally, leading to a symmetrical distribution of charge. Therefore, each atom in these molecules would have an equal share of electron density, resulting in no partial charges across the molecule. However, in larger nonpolar molecules, such as hydrocarbons like methane, CH4, or ethane, C2H6, although individual bonds may be polar due to differences in electronegativity between carbon and hydrogen, the overall molecule remains nonpolar due to its symmetrical structure. In these molecules, the regions around each atom contribute to the overall nonpolar nature by distributing charge symmetrically. On the MCAT, understanding the concept of nonpolar molecules and their regions is crucial for several reasons. Biological relevance. Many biological molecules, such as lipids and fats, are nonpolar. Understanding their nonpolar nature is essential for comprehending their behavior in biological systems. Chemical interactions. Nonpolar molecules tend to interact through weak intermolecular forces like London dispersion forces. Knowledge of these interactions is vital in understanding phenomena such as solubility and boiling points. Predicting molecular properties. Knowing the regions within nonpolar molecules aids in predicting their physical and chemical properties, such as melting points, boiling points, and phase behavior. Analyzing reactions. Understanding the nonpolar regions within molecules is crucial for predicting how they will react with other substances, as nonpolar molecules often exhibit distinct reactivity patterns compared to polar molecules. In summary, a solid grasp of nonpolar molecules and their regions is fundamental for success on the MCAT, as it serves as the foundation for comprehending various concepts in chemistry and biology, from molecular interactions to biological processes.
Question 9. What increases chemical reactions? Discussion on what increases chemical reactions and the collision theory. Explanation of how temperature influences chemical reactions. Factors influencing chemical reactions. A college-level perspective. Chemical reactions are fundamental processes that underpin numerous phenomena in nature and are crucial in various scientific disciplines, including chemistry, biochemistry, and material science. Understanding the factors that influence chemical reactions is essential for predicting reaction outcomes, optimizing reaction conditions, and designing new processes. On the medical college admission test, MCAT, a thorough comprehension of these factors is vital, as they often form the basis for questions related to chemical kinetics, thermodynamics, and biochemical pathways. Here, we delve into the key factors that influence chemical reactions at a college level, providing insights relevant to the MCAT exam. Nature of reactants. The chemical nature of reactant molecules profoundly affects reaction rates. Reactants with high reactivity, such as highly reactive metals or molecules with labile functional groups, tend to undergo faster reactions compared to inert substances. Additionally, the presence of functional groups that facilitate electron transfer or nucleophilic attacks can enhance reaction rates by lowering activation energies. Concentration of reactants. According to the collision theory, the rate of a chemical reaction is directly proportional to the concentration of reactant molecules. Higher concentrations lead to increased frequency of collisions between reacting species, thereby accelerating the reaction rate. This principle is expressed by the rate law equations, which relate reaction rates to the concentrations of reactants and often feature prominently in MCAT questions. Temperature. Temperature exerts a significant influence on reaction rates by affecting the kinetic energy of molecules. As temperature rises, molecules possess higher average kinetic energy, leading to more frequent and energetic collisions between reactant molecules. Consequently, reactions generally proceed faster at elevated temperatures, in accordance with the Arrhenius equation, which describes the exponential relationship between reaction rate and temperature. Catalysts. Catalysts are substances that accelerate chemical reactions by providing an alternative reaction pathway with lower activation energy. They do not undergo permanent changes during the reaction and can significantly increase reaction rates without being consumed. Understanding the mechanisms by which catalysts operate, such as providing alternative reaction mechanisms or stabilizing transition states, is crucial for MCAT preparation. Surface area. For reactions involving solid reactants, such as heterogeneous catalysis or dissolution processes, the surface area of the solid phase plays a crucial role. Increasing the surface area exposes more reactant molecules to the reaction environment, thereby enhancing the frequency of collisions and promoting faster reaction rates. This concept is particularly relevant in contexts such as enzymatic reactions and industrial catalysis. Presence of solvent. In solution phase reactions, the choice of solvent can significantly impact reaction rates. Solvents can stabilize or destabilize reaction intermediates, influence the solubility of reactants, and facilitate mass transport of reactant molecules. Understanding solvent effects, including polarity, proticity, and specific solvent-solute interactions, is essential for predicting reaction kinetics and selectivity in organic chemistry. Pressure for gaseous reactants. For gas phase reactions, changes in pressure can influence reaction rates, particularly for reactions involving gaseous reactants. According to Le Chatelier's principle, increasing pressure can shift the equilibrium of a reaction towards the side with fewer moles of gas, thereby affecting reaction rates. Understanding the implications of pressure changes on reaction equilibrium and rate constants is crucial for MCAT success. In conclusion, various factors influence chemical reactions, and a comprehensive understanding of these factors is indispensable for success on the MCAT exam. Mastery of concepts such as reactant nature, concentration, temperature, catalysts, surface area, solvent effects, and pressure allows aspiring medical professionals to interpret reaction mechanisms, predict reaction outcomes, and apply fundamental principles to complex biochemical processes encountered in medical practice. Question 10. Collision theory and temperature of chemical reactions. Collision theory and temperature of chemical reactions. Collision theory is a fundamental concept in understanding chemical reactions and reaction rates. It proposes that for a chemical reaction to occur, reactant molecules must collide with each other with sufficient energy and proper orientation. This theory provides a framework for explaining how various factors, including temperature, affect reaction rates. Temperature plays a crucial role in collision theory and significantly influences reaction rates. According to the theory, an increase in temperature leads to an increase in the kinetic energy of molecules, which in turn increases the frequency and energy of collisions between reactant molecules. Effect of temperature on collision frequency. As temperature rises, the average kinetic energy of molecules increases, leading to an increase in their speed. Consequently, the frequency of collisions between reactant molecules also increases. This higher collision frequency enhances the likelihood of successful collisions, where molecules overcome the activation energy barrier and form products. Effect of temperature on collision energy. In addition to increasing collision frequency, temperature also influences the energy of collisions. The distribution of kinetic energies among molecules follows a Maxwell-Boltzmann distribution curve. Higher temperatures shift this curve to the right, indicating a greater proportion of molecules possessing energies equal to or greater than the activation energy required for the reaction. Thus, more collisions occur with sufficient energy to initiate the reaction. Activation energy. Activation energy is the minimum energy required for a reaction to occur. As temperature increases, the number of molecules possessing energies equal to or greater than the activation energy also increases. This results in a higher fraction of successful collisions, as more collisions have sufficient energy to overcome the activation barrier and lead to product formation. Reaction rate and temperature. The relationship between reaction rate and temperature is described by the Arrhenius equation. This equation states that the rate constant K of a reaction increases exponentially with temperature. Mathematically, it can be represented as K equals E minus EARTK equal E minus RTEA, where K is the rate constant, A is the pre-exponential factor or frequency factor, EA is the activation energy, R is the universal gas constant, T is the temperature in Kelvin. This equation illustrates that as temperature increases, the exponential term decreases, leading to a higher rate constant and thus a faster reaction rate. In summary, temperature influences reaction rates by affecting both the frequency and energy of collisions between reactant molecules. Higher temperatures increase collision frequency and provide a greater proportion of molecules with energies sufficient to overcome the activation energy barrier, thereby accelerating chemical reactions. Understanding the relationship between temperature and collision theory is essential for predicting and manipulating reaction rates in various chemical systems. Question 1. Voltage and energy. Which of the following statements accurately describes the relationship between voltage and energy expended in a circuit? A. The voltage across a circuit is directly proportional to the energy expended in the circuit. B. The voltage across a circuit is inversely proportional to the energy expended in the circuit. C. The voltage across a circuit has no effect on the energy expended in the circuit. D. The relationship between voltage and energy expended in a circuit is nonlinear and cannot be determined. Question 2. Similar chemical properties on periodic table. Which of the following elements is expected to exhibit chemical properties most similar to chlorine, Cl, on the periodic table? A. Fluorine, F. B. Sulfur, C. Bromine, D. Argon, Ar. Question 3. Law of conservation of mass. Which of the following scenarios best illustrates the law of conservation of mass? A. During a chemical reaction, the total mass of the reactants is equal to the total mass of the products. B. When a solid substance is dissolved in a liquid, the mass of the resulting solution is equal to the combined mass of the solid and the liquid. C. Heating a sample of ice causes it to melt into liquid water, and then boiling the liquid water results in the formation of water vapor. D. Mixing two solutions together in a beaker results in a color change, indicating a chemical reaction has occurred. Question 4. Solubility of solids. Which of the following factors does not typically influence the solubility of a solid solute in a solvent? A. Temperature. B. Pressure. C. Surface area. D. Molecular weight. Question 5. Homogeneous Solution Tyndall Effect. Which of the following statements best describes the homogeneous solution Tyndall effect? A. It occurs when light is scattered by particles in a heterogeneous mixture. B. It arises when light is scattered by particles in a homogeneous mixture. C. It is the result of light absorption by solute particles in a solution. D. It is observed when light passes through a completely transparent medium without scattering. Question 6. Salt water and boiling point. Which of the following statements best describes the relationship between salt water and its boiling point? A. Salt water has a lower boiling point compared to pure water. B. Salt water has a higher boiling point compared to pure water. C. Salt water and pure water have the same boiling point. D. The boiling point of salt water depends on the concentration of salt dissolved. Question 7. Pressure on a liquid solution. Which of the following statements accurately describes the effect of pressure on a liquid solution? A. Increasing pressure will always decrease the solubility of gases in the liquid. B. Increasing pressure will always increase the solubility of gases in the liquid. C. Increasing pressure will have no effect on the solubility of gases in the liquid. D. The effect of pressure on the solubility of gases in the liquid depends on the specific gas and solvent involved. Question 8. Nonpolar molecules and their regions. Which of the following best describes the regions of nonpolar molecules? A. They possess a distinct positive and negative end. B. They exhibit partial charges within the molecule. C. They lack an uneven distribution of electron density. D. They contain polar covalent bonds. Question 9. What increases chemical reactions? Which of the following factors is most likely to increase the rate of a chemical reaction? A. Decreasing the temperature. B. Decreasing the concentration of reactants. C. Adding a catalyst. D. Decreasing the surface area of reactants. Question 10. Collision theory and temperature of chemical reactions. Which of the following statements accurately describes the relationship between collision theory and temperature in chemical reactions? A. According to collision theory, increasing temperature decreases the rate of chemical reactions. B. Collision theory suggests that increasing temperature has no effect on the rate of chemical reactions. C. Collision theory predicts that increasing temperature increases the rate of chemical reactions. D. Collision theory proposes that temperature only affects the equilibrium constant of chemical reactions.
Question 2. Similar chemical properties on periodic table. Which of the following elements is expected to exhibit chemical properties most similar to chlorine Cl on the periodic table? A. Fluorine F. B. Sulfur S. C. Bromine Br. D. Argon R. Correct answer, C. Bromine Br. Explanation. Chlorine Cl belongs to group 17, also known as group Ca of the periodic table, commonly referred to as the halogens. Elements in this group share similar chemical properties due to having the same outer electron configuration of Ns²Mc, where N represents the outermost energy level. Thus, the correct answer is option C, bromine Br. Let's examine why the other options are incorrect. A. Fluorine F. Fluorine is also a halogen, like chlorine, and it is located directly above chlorine in group 17. While fluorine does share similar chemical properties with chlorine, it is not the best choice among the options provided because fluorine is smaller in size and exhibits stronger electronegativity compared to chlorine, leading to some differences in reactivity. B. Sulfur S. Sulfur is located in group 16 of the periodic table, known as the chalcogens. While sulfur shares some chemical properties with chlorine, such as forming covalent compounds, it is not the most similar element to chlorine because it belongs to a different group and has a different outer electron configuration. D. Argon. Argon is a noble gas located in group 18 of the periodic table. Noble gases are characterized by their very low reactivity due to their stable electron configurations. Argon does not share chemical properties similar to chlorine since it does not readily form chemical bonds like chlorine does. In summary, the correct answer is C, bromine, because it belongs to the same group as chlorine and thus shares similar chemical properties due to having the same outer electron configuration. Question 3. Law of conservation of mass. Which of the following scenarios best illustrates the law of conservation of mass? A. During a chemical reaction, the total mass of the reactants is equal to the total mass of the products. B. When a solid substance is dissolved in a liquid, the mass of the resulting solution is equal to the combined mass of the solid and the liquid. C. Heating a sample of ice causes it to melt into liquid water, and then boiling the liquid water results in the formation of water vapor. D. Mixing two solutions together in a beaker results in a color change, indicating a chemical reaction has occurred. Correct answer. A. During a chemical reaction, the total mass of the reactants is equal to the total mass of the products. Explanation. A. This option accurately describes the law of conservation of mass, stating that matter cannot be created or destroyed in a chemical reaction. The total mass of the reactants is always equal to the total mass of the products. This principle is fundamental in chemistry and is observed consistently in various reactions. B. While the mass of the solution does indeed equal the combined mass of the dissolved solid and the liquid solvent, this scenario doesn't directly pertain to the law of conservation of mass, which specifically concerns chemical reactions. C. This scenario involves physical changes, melting and boiling, rather than chemical reactions. The law of conservation of mass applies strictly to chemical reactions where substances are chemically transformed into new substances, not to changes in state. D. A color change in a solution indicates a chemical change, but it doesn't directly illustrate the conservation of mass. This scenario might involve a chemical reaction, but it doesn't address the fundamental principle that the total mass of substances remains constant in a chemical reaction. In conclusion, option A is the correct answer because it accurately represents the law of conservation of mass by stating that the total mass of reactants equals the total mass of products, which is a fundamental principle in chemistry. Question 4. Solubility of solids. Which of the following factors does not typically influence the solubility of a solid solute in a solvent? A. Temperature. B. Pressure. C. Surface area. D. Molecular weight. Correct answer. Pressure. Explanation. A. Temperature. Temperature often has a significant impact on the solubility of solids in liquids. Generally, as temperature increases, the solubility of solids in liquids also increases, although there are exceptions depending on the specific solute and solvent. B. Pressure. Unlike gases, pressure has a negligible effect on the solubility of solid solutes in a solvent. This is because solids are not significantly affected by changes in pressure, unlike gases which show a direct relationship between pressure and solubility, Henry's law. C. Surface area. Surface area can influence the rate of dissolution rather than the solubility itself. Increasing the surface area of a solid solute by grinding or crushing it into smaller particles can accelerate its dissolution because it exposes more solute particles to the solvent, thus increasing the rate at which solute particles can come into contact with the solvent. D. Molecular weight. In general, larger molecules tend to have lower solubility in a given solvent compared to smaller molecules. This is because larger molecules have stronger intermolecular forces and are less likely to be surrounded by solvent molecules, reducing their solubility. In summary, while temperature, surface area, and molecular weight typically influence the solubility of solid solutes in a solvent, pressure does not have a significant effect. Therefore, option B is the correct answer. Question 5. Homogeneous Solution Tyndall Effect. Which of the following statements best describes the homogeneous solution Tyndall effect? A. It occurs when light is scattered by particles in a heterogeneous mixture. B. It arises when light is scattered by particles in a homogeneous mixture. C. It is the result of light absorption by solute particles in a solution. D. It is observed when light passes through a completely transparent medium without scattering. Correct answer, B. It arises when light is scattered by particles in a homogeneous mixture. Explanation: A. Incorrect. The Tyndall effect is not associated with heterogeneous mixtures. In heterogeneous mixtures, light is scattered by the larger particles, giving rise to the phenomenon known as scattering, not the Tyndall effect. B. Correct. The homogeneous solution Tyndall effect occurs when light passes through a homogeneous solution and is scattered by solute particles within the solution. This scattering is responsible for the visibility of a beam of light passing through a colloidal solution, giving it a visible path. The term homogeneous here refers to the uniform distribution of the solute particles throughout the solution. C. Incorrect. The Tyndall effect is not caused by light absorption by solute particles in a solution. Instead, it is due to the scattering of light by these particles. D. Incorrect. The Tyndall effect is characterized by the scattering of light as it passes through a medium containing suspended particles, leading to the visibility of the light path. This effect is not observed in completely transparent media where there are no particles to scatter the light. Therefore, option B is the correct answer as it accurately describes the homogeneous solution Tyndall effect and distinguishes it from the other options.
Question 9. What increases chemical reactions? Which of the following factors is most likely to increase the rate of a chemical reaction? A. Decreasing the temperature. B. Decreasing the concentration of reactants. C. Adding a catalyst. D. Decreasing the surface area of reactants. Correct answer, C. Adding a catalyst. Explanation: A. Decreasing the temperature. Lowering the temperature typically slows down chemical reactions according to the Arrhenius equation. This is because fewer reactant molecules possess the necessary activation energy to overcome the energy barrier and react. Thus, decreasing the temperature would not increase the rate of the reaction. B. Decreasing the concentration of reactants. According to the rate law, the rate of a reaction is directly proportional to the concentration of reactants. Therefore, decreasing the concentration of reactants would actually decrease the rate of the reaction, as there would be fewer reactant molecules available to collide and form products. C. Adding a catalyst. Catalysts are substances that increase the rate of a chemical reaction by providing an alternative pathway with a lower activation energy. By lowering the activation energy, catalysts enable more reactant molecules to successfully collide and form products in a shorter amount of time. Thus, adding a catalyst increases the rate of the reaction. D. Decreasing the surface area of reactants. Increasing the surface area of reactants typically increases the rate of reaction, especially in heterogeneous reactions where one or more reactants are in a solid state. This is because a larger surface area exposes more reactant molecules to potential collisions, thereby enhancing the frequency of effective collisions. Decreasing the surface area would have the opposite effect and decrease the rate of the reaction. Therefore, the correct answer is C, adding a catalyst, as it directly facilitates the reaction by providing an alternative reaction pathway with lower activation energy, leading to an increase in the rate of the reaction. Question 10. Collision theory and temperature of chemical reactions. Which of the following statements accurately describes the relationship between collision theory and temperature in chemical reactions? A. According to collision theory, increasing temperature decreases the rate of chemical reactions. B. Collision theory suggests that increasing temperature has no effect on the rate of chemical reactions. C. Collision theory predicts that increasing temperature increases the rate of chemical reactions. D. Collision theory proposes that temperature only affects the equilibrium constant of chemical reactions. Correct answer, C. Collision theory predicts that increasing temperature increases the rate of chemical reactions. Explanation. A. Incorrect. Collision theory states that increasing temperature actually increases the rate of chemical reactions. This is because higher temperatures lead to greater kinetic energy among reacting molecules, resulting in more frequent and energetic collisions, which in turn increases the likelihood of successful collisions and thus increases the reaction rate. B. Incorrect. Collision theory clearly indicates that temperature does have an effect on the rate of chemical reactions. Higher temperatures generally lead to faster reaction rates due to increased molecular motion and collision frequency. C. Correct. Collision theory predicts that increasing temperature increases the rate of chemical reactions. This is because higher temperatures provide reacting molecules with greater kinetic energy, leading to more frequent and energetic collisions, which increases the likelihood of successful collisions and thus accelerates the reaction rate. D. Incorrect. While temperature does affect equilibrium constants, collision theory primarily concerns itself with the rates of chemical reactions, not their equilibrium constants. Therefore, this statement is unrelated to collision theory's explanation of the effect of temperature on reaction rates. Yo, it's the med student life, but it's a bumpy ride. In this world of medicine, where's the guide? Relationship conflicts like a storm in my heart. In this battle of love, where do I start? Late nights in the library, but you're not by my side. In this pursuit of knowledge, feeling denied. Phone calls unanswered, texts left on read. In this world of medicine, feeling misled. Trying to balance love and the stethoscope. In this struggle for balance, where's the hope? Caught between textbooks and late-night calls. In this medical journey, hitting the walls. In the hustle and the grind, but my heart's in a bind. Relationship conflicts got me feeling confined. In this world of medicine where I'm trying to find, I'm just a med student, caught in the grind. Arguments over missed dates and forgotten plans. In this relationship maze, where's the bands? Jealousy creeping in like a silent thief. In this world of medicine, feeling the grief. But I'll fight for us with every beat of my heart. In this medical journey, we'll make a new start. Communication key in this dance of love. In this world of medicine, we'll rise above. Making time for us in this chaotic race. In this pursuit of love, finding our space. No longer letting conflicts tear us apart. In this medical journey, we'll mend the heart. In the hustle and the grind, but my heart's in a bind. Relationship conflicts got me feeling confined. In this world of medicine, where I'm trying to find, I'm just a med student, caught in the grind. So I'll cherish the moments with you by my side. In this journey of love, we'll take the ride. No longer letting conflicts cloud our view. In this medical world, our love will renew. Yo, it's the med student grind, but with you I'll fight. In this world of medicine, love's our light. No longer feeling confined. In this relationship so true, in the world of medicine, I'll find my breakthrough. A few meditations from the Word of God. Romans 18-17, the Spirit Himself testifies with our spirit that we are God's children. 17, now if we are children, then we are heirs, heirs of God, and co-heirs with Christ, if indeed we share in his sufferings, in order that we may also share in his glory. Numbers 14, 1-2 in IV. That night all the members of the community raised their voices and wept aloud. Second, all the Israelites grumbled against Moses and Aaron, and the whole assembly said to them, "If only we had died in Egypt, or in this wilderness." Timothy 1:7 in IV. For the Spirit God gave us does not make us timid, but gives us power, love, and self-discipline. Survival question alert. How do you budget and spend your money? Please comment below. How has understanding chemistry impacted your perspective on everyday phenomena? Please comment down below. If you enjoyed this video, don't forget to like and subscribe for more educational content on chemistry and science. Hit the notification bell to never miss an update from us. Thanks for watching. Hello there, I am Angelique Granville, and I'm a professional listener, digital products entrepreneur, and content creator. I have a degree in biology from Adelphi University, and I am passionate about helping allied health professionals succeed. I am here to help you get into medical school. On this channel, I share my tips and hacks on how you can pass your entrance exams so you can get into medical school. Do you want to talk to me for an hour about your life and your problems? Check out my therapy programs. The link is in the description. It says, "Let me help you in life." If you are getting value from this content, I urge you to like, subscribe, and share this video with all of the pre-medical students, biology students and majors, physics majors and engineering majors that you know. If you know anyone who is struggling to study for the MCAT, please tell them about the Hospital Near Me Medical Career Training channel. Together, we can conquer you getting into medical school and feel better about being accepted by the college of my choice. Please hit the notification bell so that you never ever miss another one of my videos. If you haven't already liked this video, make sure to give it a big thumbs up and send this video to at least 3 people. I know you can think of them. If somebody pops in your head right now, and send it to them. WhatsApp, Facebook, TikTok, LinkedIn, and Instagram. Challenge them to do it with you, and you can get results together. Come and take my easy MCAT exam. If you are getting value from this channel, all I ask is that you let my ads play on the video. And if you could bless my Paynzo, Cash App, Venmo, Buy Me a Coffee, GoFundMe, Patreon, or give me a thank you donation of $1 to $5, or with a donation of any amount, it would be greatly appreciated. I'm saving up for a new home as my old one got severely damaged in Hurricane Sandy and left me homeless. I want to thank you for watching the Hospital Near Me Medical Career channel for allied health professionals. I look forward to being a part of your medical school journey and being a part of your own growth. Walk with God. Thanks a bunch. Thank you for watching, and stay tuned for the Shopping Network.
Bless me.